Newton 2 in momentum. Let's just quickly remind ourselves what Newton 2 actually means. Newton 2 suggests that when a resultant force acts on an object, the object will accelerate in the direction of the net force with an acceleration that is going to be directly proportional to the force and inversely proportional to the mass. So when we start to look at Newton 2 in terms of momentum, we need to consider that momentum has a formula that we can now incorporate in some way. So if you look at F net equals ma, we must also remember that a is actually the change in velocity over the change in time. Or we can say that acceleration is the rate of change in velocity. So if we substitute this into our formula, it tells me that F net is actually equal to m multiplied by the change in v over the change in t. And we learned that momentum equals mass multiplied by the change in velocity. So now we can substitute p into this formula, and then we're going to end up with F net equals a change in p over a change in t. So we can actually say that the net force is going to be equal to the rate of change in momentum. And this is super important, and it's actually a more accurate way of talking about net forces. So I'm going to just focus on an example where we have velocity and momentum of an object, and we're going to see what happens here. I've got a question where there's a car that is at the moment moving at a velocity of 25 meters per second. The direction is given as west. Then there will be a braking force and a friction force that will work on the car. So before we had the braking force and the frictional force, Newton's first law was applicable. Why Newton's first law? Because the car was moving at a constant velocity, which meant that the resultant force was zero. But now that we have a braking force and frictional force, the braking force and the frictional force will result in a net force. So we can actually say that our net force is going to be equal to the braking force. I'm just going to call it F subscript B, as well as the force of friction, F subscript F. You remember from grade 11 perhaps that the net force is equal to the sum of all the forces acting on the object, where we just take a sign into consideration for direction. So the direction of motion at the moment is going to be to the west, and my braking force and my frictional force will be to the east. So because both my braking force and my frictional force is to the east, both of them are going to be negative. Can you see that? If I decide that west is positive, because the braking force and the frictional force will basically be east. So at the moment, my direction of motion is going to be west or to the left. My net force is going to be to the right. And if I look at my formula, if F net equals a change in P over the change in time, the change in time is always going to be positive. So if the net force direction is east, it must mean that the change in momentum must also be east. Just keep that in mind. Then, after the braking force and the frictional force has now been applied for 6 seconds, the new velocity is now 10 meters per second. And this is also going to be west. So we see that we have a change in our velocity from 25 meters per second. An object decreases its velocity to 10 meters per second. They've also given us the mass of the car here as 800 kilograms. So our first question is to calculate the change in momentum. So this is our unknown, change in P. When you want to calculate change in P, the simplest way of solving this is to use our formula change in P equals mass multiplied by the change in V. So if I take west as positive, remember then we have to stick to it all throughout our questions. This is going to be equal to the mass is already in the SI unit, kilograms, 800, multiplied by the change in V, which is actually the final velocity minus the initial velocity. So my final velocity was 10 meters per second. I subtract my initial velocity of 25 meters per second. So what I end up with here is 800 multiplied by 10 minus 25, which is actually 800, that's going to be multiplied by negative 15. And this is going to give you an answer of negative 12,000. And momentum is kilograms meter per second, which means that my change in momentum is actually going to be 12,000 kilograms meter per second, and then the negative sign tells me that it's to the east, which is correct according to what I said earlier here, that my change in momentum must be to the east. So this answer of ours then makes sense to say it's 12,000 kilograms meter per second east. The next question, calculate the net force that will be acting on the car. Now we use this formula where we say F net equals the change in P over the change in T, where I substitute my answer as a negative 12,000, and I'm going to divide that by the time, 6 seconds, and this is going to give me an answer of negative 2,000 Newton. Remember, net force is always measured in Newton, and remember that net force is a vector, so we have to add direction. This negative tells me that my answer is actually 2,000 Newton east. So this formula is just a way for us to now express Newton 2 in terms of momentum.